Okay, this week I'm doing a live in-person chat with William Mathewson. You would probably know him best as the WMD guy, and I got to first run into his work a couple of years ago. I did a review for a magazine of one of his guitar pedals. It blew my head off. It was so cool. And then he started getting into modules about the same, when I was getting into modules. And I've kind of bounced in and out of different WMD modules. And it also turns out that he's got quite a little production facility. So we're actually in his office, in his production facility. So I just got a tour around, got to see some of the equipment that makes modules that we all know. So with that, I'm going to say hi to William. Hi, William. How are you?
Hey, doing great, Darwin.
Thanks a lot for letting me come by for a visit and for showing me around. That first of all, that was really cool.
For sure, yeah. Thanks for setting this all up.
Yeah, this is neat, and I'm really glad to get to talk to you because, to me, to my mind, you're doing some of the most inventive modules that are being put out there right now. I really find your stuff to be pushing the envelope of what people are doing. Now, I think a lot of people, when they think about modular systems, kind of think sort of like a modern equivalent of the Moog, right?
Yeah, of course. A lot of people want to do kind of a standard subtractive synthesis thing, and that's great. It sounds great. There's a lot of companies out there that make really nice modules that are based on that old stuff, and it's a lot of fun to be able to hook them up in a different way, and not the mini Moog fixed architecture.
Right.
Yeah.
But you make stuff with names like the Hadron Collider,
yeah.
which, quite frankly, it looks like you need a nuclear physicist degree just to figure out what's going on there.
Yeah.
It looks like some incredible complexity in some of the stuff you've been doing.
I try to, when I approach a new design, I always try to think of something new. I don't base my stuff on things that have been done, or try not to. I mean, there's only so much you can do with electronics and how things go together, and you gotta make something that operates in the musical domain.
Right.
But I try to come up with stuff that's going to be either interesting or weird, or just a different approach than what's been done, like especially compared to classical synthesis.
Right. And what's interesting to me is that a lot of times you're sort of pushing the envelope in terms of what people expect out of a musical instrument. I know certainly in having played around with like your VCAs and your envelopes, some of the timings are shockingly fast, in comparison to what people are typically used to.
I do a lot of that development on the oscilloscope, and I'll say, I bet I can make that faster, or make it do something that I can see before I go to how it sounds.
Right.
So, like with the I guess regarding VCAs, the digital VCA was a joke. I was talking to student Thai guy on the phone, and he said, it would be stupid. Why would we do this? But if we made a digital VCA, it's the most analog thing there is, VCA.
Right.
And let's make it digital. Let's make it complicated. Let's make it weird. And then I looked at it and I said, I know how to do it. We could do it with a digital potentiometer. And then you have like some aliasing that'll happen because you have to sample the CV.
Right.
And ended up that in the data sheet for the digital pot that I use, the analog devices thing, there's a zero crossing detector that I looked at, and I said, this would be super musical if we did this.
All of a sudden the joke becomes
reality.
This
great module that people use for eliminating pops and clicks and making really tight bass lines.
That explains, because I was wondering how something that was that responsive wasn't as click prone as other things I've used. That's interesting. I hadn't thought about that, but that is something that you would get in a digital domain, isn't it?
Yeah, you have the power to make things wait in digital.
Right.
You have the power of time.
The power
in
of
digital.
time.
Yeah.
So one of the things I like doing in my podcast is asking people about their background, and how they got to be the maker, creator, builder, artist, or whatever. And I would say in your work, you really kind of combine all those things, because you do some highly technical stuff. Certainly the oscillators, but even really, I take a look at your the MME, the multi-mode envelope, which is an envelope that sort of embodies every envelope, right?
With that, I wanted to make an envelope that. So I looked at a bunch of reference designs, old stuff, ADSRs. I wanted voltage control.
Right.
So, but I didn't want to do it in kind of the classical way. I didn't want to use Vactrols
Right.
to change your resistances. So
Right.
what the multi-mode envelope really is a triangle core VCO, where instead of it running all the time, it just has there's a microcontroller that tells it when to go up, when to go down, and then there's feedback for determining the curve of each segment. So it's not a standard envelope generator at all. It's a VCO that's been heavily modified.
That's crazy. Well, see, now I'm like learning about what's knocking around inside your head. That's pretty interesting. I would have never thought of an envelope as really being a special case oscillator. That's pretty cool.
Yeah.
So I'm curious, and one of the things I like doing on my podcast is talking to people about their background, how they get to be what they are.
Sure, yeah.
How does someone get to be this combination of designer, manufacturer, but also a lot of your stuff is has a lot of artistic built into it too. How do you combine all those things? Where are you coming from?
So I started out being a musician in high school, playing around. I was in the demo scene and doing trackers on the computer for a long time, and liked sampling, like messing around with that, and had a access virus my parents bought me, which was super cool. So that got me into doing synthesis, the digital side, but on the very analog kind of interface.
Feeling, yeah.
Yeah, analog feeling, yeah. And then I was lucky enough to land a gophership in a recording studio. So I'd go get coffee, I'd do evening recordings of like high school bands and choirs, and I'd hang out with the engineer and owner, a guy named Jeff Gray, who lives in Boulder, Colorado, still runs his studio. Some of you probably know him.
Right.
Yeah. And
interesting.
And he just let me hang out and learn about recording and sit in on sessions and get some chops up working with signal flow and stuff like that. And then I've always had some interest in electronics. So tinkered, made some pedals that never really sounded good in high school, and I made a little rack of distortion boxes that were just guitar effects pedals put into a rack mount system for running my own stuff through. So I'd always tinkered. And then in college, I had a couple clients through the studio that wanted custom pedals, so I made them and tweaked a couple things, did what the clients wanted, and said, this is kind of cool. Maybe I should look into this some more, see if we could turn this into a real thing. And so I did a short run of 10 Fat Man pedals, which was our first envelope filter.
Okay.
And sold a few of them, and then did a run of 80, and then reached out to Sean Cleary, Analog Haven, and he bought the first 10, and I was like, well, this, now I'm actually in business. I can do this.
Right.
And then I spent a summer, I had a day job working as a mechanical engineer, and then spent my evenings in the summer working on the Geiger counter, developing it. Taught myself assembly language for that, and threw some parts together to make a distortion circuit and a tone control, and hooked up all the interface stuff for the micro, and made this thing. And then I sent one to Sean, and he bought 25 right away. He called me at like 8 o'clock at night and said, I want 25, I want them immediately. And that was when it really started to take off.
Interesting. So I'm curious, how did you get from, because this is the point where electronics kind of halted for me for about 20 years. I was into guitar pedals, and I actually got to the point where I made a nice little rack-mounted thing where I was able to put all my pedal boards, tear the pedal boards out of the pedals and put them all in this thing so that I had a nice rack full of stuff.
Yeah.
But I never made the next step, which was like modifying and then like building stuff from scratch. How did you make that leap? Because that to me seems like a pretty big chasm.
I just sat and messed with stuff. Really, I just sat in my garage and had a a pedal that I built from a kit or from, you buy the circuit board and
Right.
build it up, and just seeing what I could short out, if I could make it do something. Hey, it's kind of it's really basic circuit bending.
Yeah, I was
type
going to
stuff.
say it
Yeah.
sounds like classic circuit bending.
Yeah.
Except you ended up with products out of the back end of it.
Yeah, well, I'd take something and I'd apply the little bit of knowledge I had at the time, which was how to make an op amp work, and invert something, add these two signals together, and then you could make this subtractive distortion type thing.
Sure.
And,
Okay.
a lot of this stuff never came out because there's just lots of time of things
Experiments.
screwing around.
Right.
Screwing around making sounds. And eventually turned into, okay, I think what is enough original stuff to actually make a real product.
Right.
Yeah.
So now I'm curious about the step from making distortion boxes or like envelope followers, which there's some like classic designs that you could at least be informed in,
Mm-hmm.
to the Geiger counter, which is this waveform follower kind of a thing.
It seems more complicated than it is.
Okay.
The Geiger counter there's a distortion, and then there's a computer. It takes there's an analog to digital converter, turns your signal into numbers, and then spits it back out with a digital to analog.
Okay.
And there's a little microcontroller in there, and all the microcontroller is really doing is it reduces the bit depth on the input. It applies a mask to it, so you get less fidelity out. It slows the rate at which it's sampling things. That's your sample rate knob.
Right.
And then there's a wavetable modulator. Sounds complicated, but it's just
It's a remapper, basically.
it's a lookup table.
Yeah, right.
It's a lookup table and a bunch of interesting waveforms that I drew on my graphing calculator. Figured out how to get it to be a binary and just program it into the micro as a lookup table.
Yeah.
And
So when did this come out? When did the Geiger counter first?
Geiger
come out?
counter came out October 2008, 2009.
Okay.
It was 2009.
Wow, it seems like it was a lot longer ago than that.
Yeah.
But there you go. That's really cool. So now, one of the things I'm curious about, it sounds to me like Sean Cleary at Analog Haven was pretty much responsible for like wedging you into the business world.
Yeah, he said he took the Geiger counter, he sold quite a good number of them, and helped put me in business, and said, I'm doing a lot of Euro modules, this would be a cool piece. So he invested in me and said, I'll buy the first 100 and make them.
Uh-huh.
So I worked on it over, I think it was the next summer, and ended up with the Geiger counter Euro module.
Had you met him much before that?
I never met him in person. Yeah.
He just, it's funny because Sean is like a thread that kind of exists through. I've done interviews with a number of different modular makers, and he consistently comes up as an important influencing factor on this industry even existing.
He's the guy who would send people money, myself included, and say, make something, I can sell it, and then you'll make more. And there's no contract. It's just an over the phone or email deal where he just wants the first shot at something, and he wants you to design your thing and put it into a format that he can sell. And he's responsible for making the industry what it is. He started out a lot of these companies, a lot of us guys from 2008, 2009, 2010, 2011 really got us to make stuff and to turn our kind of DIY hobby thing into real businesses.
Right.
Yeah.
So now, since the development of that first Geiger counter module, you now have a pretty full range of products. I mean, you have enough to do more than one kind of synth voice at this point.
I think we've got 16 or so WMD modules, and then Andrew Morelli from SSF and I put out a line of 10 modules that debuted at the beginning of this year at the WMD SSF collaboration line.
What to you is the differentiation between those two product lines?
Those two, Andrew and I developed them together. We co-engineered those.
All right.
Yeah.
Interesting. Okay.
Yeah.
But like, if somebody is looking to get some modules, how do you expect the customer sees the difference?
So the concept behind the WMD SSF stuff was we both wanted to make kind of more basic modules that were interesting in their own way. They were really good at what they did, but they weren't like crazy modules. They were basic synthesis modules for kind of more standard synth stuff. And so we worked together on it. We didn't want to put out two totally separate lines.
Right.
So we decided to collaborate on it, and the
modules
came out really, really well.
Yeah. Now, when I first saw those, they were also in one of the new monolith cabinets. I think it was, in fact, your first prototype, maybe.
Yeah. So the monolith is a keyboard case that we basically bought from Dave Phipps from Super Synthesis. It's his case. He did the design work on the case.
Yeah.
We worked with him a bit to spec it out for what we wanted.
Right.
And bought them from him.
I didn't realize, because I remember that thing, and mostly what I remember about it was that it was unobtainable, it seemed, right? But I always thought, well, that'd be really cool if I could get one of those, but I will never be able to get one of those. and then you came out with it, and I was like, all right, well, this is going to make it so that they're going to be available. I didn't realize that it was actually built off his design.
Yeah, we saw it. He sent one to the NAMM booth that we were at, and we jumped on it. We said, I love this thing. It's great. It's going to make a really good product. So we just need to fill it with modules, and Andrew and I were working on our set of stuff and just put it all together, and it timed out.
Yeah, that certainly makes sense. Well, again, the idea of taking maybe some more basic modules but combining with a keyboard front end, that just really really makes a fantastic entry system.
Yeah.
Especially for people that are coming from something like an Axis virus or something where they already have a sense of synthesis.
That's what we wanted. It's not going to be somebody's first synthesizer. It's too expensive. It's $2,600.
Right.
But it can be somebody's first modular system if they're coming from a mini Moog, coming from a virus, coming from some place where they're in a fixed architecture and they want to be able to experiment more, but still be able to play it. It's for players. Yeah.
It's really that's really smart, and it's a really sharp looking system too.
Yeah, it came out really nice.
Yeah. So, in all the modules that you've been involved in designing and putting out, what's your favorite? What's like your personal? What's your personal piece?
My personal favorite module that I've designed is the Synchrodyne. It's just weird, and it has a really
I've never even used one.
Oh, really?
Can you tell me a little bit about what it is?
So the idea was I have this filter chip, and it requires a high-speed clock. It's a switch capacitor filter. Filter sounds pretty good. At first, I was trying to do a multi-band parametric equalizer with it, but you get too much band crosstalk with the clocks. So I decided to make a synth module out of it, and I wanted to do it all analog. It requires a clock that is 50 or 100 times your cutoff frequency. So to get a 1 kilohertz cutoff, you need 100 kilohertz clock. So that's relatively easy to do with like a microcontroller and do it digitally, but I wanted to try and do it in analog domain. So I came up with it's just a standard Sawcore VCO, and then a phase lock loop to multiply the frequency. And most of the sound of the filter is from the phase lock loop fighting with itself.
Fighting with itself, sure, of course.
Yeah,
so that whole thing, phase lock loops are amazing because it seems like they never work right. They just work in interesting ways.
Yeah, they're always glitchy. It's this feedback thing where you're behind and then you're trying to predict what's going on. You have overshoot and undershoot, and if you balance it, it's phase locked. But then when it's not, you get all these really interesting glitches.
Yeah, no, that's interesting. That's it's funny that would be What makes it special to you? Is it just because you tripped on something and
I built the whole thing on a breadboard with just playing with parts, and it was one of the first designs I'd done that with in a long time, where I didn't really have, I had a concept of what I wanted it to do, but I let it happen organically just by tinkering and playing, and I had the whole thing breadboarded out before I ever made a prototype.
Right.
Most of the time I make a prototype on a PC board and it's surface mount and I cut traces and have to hack it all up, but this time I had the whole module more or less done before I even went to prototype.
Yeah.
It was just a really fun experience to do it that way.
Sure. Well, now you have kind of a working environment that's going to be different from most in that if you want to do a surface mount board, it's a matter of going into the next room.
Well,
Yeah.
it is and it isn't. So when we started out, we did 2 through-hole designs, the Fat Man and the Geiger counter
Okay.
at first, and then we ported over the Geiger counter to surface mount, and shortly then after the Super Fat Man was all surface mount. Everything past then was surface mount.
Okay.
But we didn't have a pick-and-place machine, so we did everything by hand with tweezers and a soldering iron, one part at a time.
So when you're talking about, we went to lunch and he mentioned something about building boards with tweezers. I thought you were talking about using tweezers on a through hole. You're talking about hand-doing surface mount. Because that seems to me like a sure way to at least lose your eyesight at very least.
Well, we've got these magnifiers, and it's about having good quality irons.
I guess, yeah. Oh,
having the right tools.
God.
You get, the 3-star tweezers, and it's not so hard. So
I don't know. It still sounds overwhelming to me.
Yeah. One of my guys, Phil, who's still here, he started with me in 2008, is used to do that day in and day out. He'd take a part, pull it out of the bin, put it on the board with tweezers, and it wasn't done with solder paste, it was with the iron. We'd put solder on half of all the pads, and then put the part on, and then solder it later.
The other.
Yeah. We still do that today for prototypes. I still build prototypes by hand. It's not worth setting up the pick-and-place machine for that. It'd take 3 hours to set up the pick and place to run a single board that we could just do in 2 hours by hand. So, I don't want to load a reel onto the machine
I hear
30 times to pick up one part.
One time, yeah, I get it.
Yeah.
That's amazing, though. That's wow. I didn't realize that that's what you're talking about when you're talking about tweezers. That's unbelievable. So you're saying that really those first kind of production runs after the through-hole, but some of those production runs were all literally beads of sweat on the board while you were putting little pieces on a time.
The first 500 Geiger counter pedals, the first 300 Geiger counter modules, I think the first 300 Hadron colliders.
Unbelievable. Wow.
Yeah. Yeah, a lot of stuff. We got the pick-and-place machine our first one, right around a little after I'd gotten orders for the Synchrodyne and the phase displacement oscillator. And that's when I said, okay, well these boards Synchrodyne has, I think, 280 parts.
Okay.
So to do one, it's a lot of hours.
Right, indeed.
A lot of time.
Well, and then all of a sudden you hit the economics of saying, is there any way I can charge enough for this to cover that time?
Mm-hmm. Yeah. And the time frame, people wanted them, and I was booked out, 6 months just on that stuff. That's with me working and not doing design work.
Right. Yeah.
So that's unsustainable.
Well, let's talk about that a little bit, because I find it. You now do manufacturing for a lot of people, and you get to see sort of like the quantities people work. When I first started getting involved in modular stuff, where I wasn't just a consumer, was when I was working with Grant Richter, doing the very first wired modules. And back then, a run of modules was like doing 5 modules, right?
Yeah.
And then you would kind of wait around, and people would send money and hope that sometime in the next 2 years you might make one. And conversely, we'd make these modules, and there was so much expense involved and all that stuff that you couldn't make a bunch that were going to sit on a shelf. And there was no such thing as retailers at the time that were going to hold any of the inventory anyway. Now, it certainly seems like, I mean, just in terms of talking to people that are doing retail sales and stuff, they're buying in quantities that just never existed back then. I mean, the business of modular synthesis has turned into something where quantity actually matters now, right?
Yeah, a typical run for us is 300 to 500 pieces.
Really? Wow.
Yeah. And then smaller reorders. But in an initial run, that'll last us a year. Which is because we don't want to be doing reruns right away, because that's not.
Well, there's expense involved in it. Setting up
all the setup,
right.
All the test fixture setup, and just everything all at once, and you save money when you buy more parts.
Right. Yeah, of course.
So we try and do really large runs so that we can sit on them for a year, including all dealer sales and everything.
Right.
So we don't have to do it that often. It's simpler.
So, like, how many, I don't even know this off, I mean, I can name like 4, but I know there's a bunch more. How many retailers are there right now out there? Are there a dozen?
There's at least 25.
Oh, really?
Yeah.
Oh, interesting.
Yeah, worldwide. There's quite a few worldwide, and there's
the
more and more coming up all the time.
Yeah, like I know the couple 3 in the U.S. and Schneidersboro, but
yeah, there's quite a few more in the U.S. now.
Yeah.
It's great. There's dealers. There's several in New York City, of course, plenty in California.
Right. There's Detroit Modular, right?
There's Chicago now.
Who's doing it in Chicago?
Rock and Roll Vintage.
Oh,
it's a parent company. Yeah, it's called Synth City.
Oh, okay. I've heard of them.
Yep.
Oh,
they popped up recently. I mean, Rock and Roll Vintage has been around a long time.
Right. Well, it's good that Chicago has one, because I used to
live
up there,
scene
and
out there.
There's a lot of modular people there, surprisingly.
Yeah.
Maybe not surprisingly, given how big of a city it is.
Right.
But so it's really kind of a changing business. Now, one of the things that I heard a lot last year at the NAMM show was people starting to talk kind of like a little scared about, there being a modular synth bubble, and it's going to all burst, and it'll be like 1981 again when everybody goes broke. That certainly doesn't seem like it's happened.
Well, it's impossible to predict the future, of course. You never know what's going to be cool. But we're also, with the internet and in the world we live in, there's no more monoculture anymore. Now everything is cool. You can do anything, and it's cool. You find your niche. So things don't really come and go in fads unless it's major mass market. We're still in a small enough market where we don't have to care what people are into, because there's enough people into what we're doing. We get to do it.
Well, and it sort of is kind of the sweet spot of boutique stuff, which is that you have people that are interested in what you're doing. But now, to what extent do you think that continued growth in the market is going to be based on innovative designs rather than just pumping out modules? Because I would think that we at least have to be at the point where a stock ADSR, we don't need more of those designs.
Well, there's starting to be a little bit of race to the bottom stuff where people are coming out with cheaper and cheaper modules, and that we'll see what happens with especially things being made overseas. If we start seeing $30 full-featured oscillator modules and stuff, it's gonna price out some people. But it's also not, because most of us established guys have our high-end market. We're in the high end of the market. So
although what's funny to me, and this is the thing that makes me love modular stuff, because prior to modular, I had tons and tons of keyboards, and keyboards come in unit costs of $2,000, right? But modules, you can get a unique, fun, or even sometimes amazing module for a couple of $300.
Yeah.
So in very first world terms, for an affordable amount of money, you can get some really unique designs. Now, I'm curious about how you see marketplace really supporting that, because you're a designer as well as all the other stuff, so you know exactly how much sweat goes into one of these designs. Do you feel like you get enough return on the design, or enough financial return to support the continued work of design?
I generally make things work at, if I can do just this one run, it's gonna pay my bills. I'm gonna be fine.
You're gonna be pleased with it.
I can do one run, and it can be as small as 100 pieces, and that will be. I'm not planning on doing 1,000 of $800 module. That would be that's insane. Right? You're gonna lose your shirt on that.
Yeah, right.
So as far as design goes and continued innovation, I think that's what's going to help drive the continued growth. Coming out with new, interesting things, and that's been really possible with all of the cheap ARM microcontrollers that have come out. You're getting a lot of really great digital modules with the analog interface now. Mm-hmm. So much more so than was possible 5 years ago.
Yeah, well, it's interesting you say that, because like 5 or 6 years ago, I actually kind of sniffed around doing some of that, and extraordinarily, I mean, so expensive it was clear that there wasn't going to be a way to come out of it alive, right, financially.
Mm-hmm. Yeah.
And so that is kind of interesting that that's changed. But also, back in the day when I was working with Grant, there was no equivalent of the manufacturing facility you have here, right? Yeah. So at that time, it was really messy time to try and do electronics, because most of the companies that were doing assembly were kind of excited because they were getting a chance to make cell phones. Mm-hmm. And so for them, quantities of less than 1 million were ridiculous.
Didn't matter.
Yeah, you weren't even on their map, right?
Yeah.
And to try and get faceplates, I remember the hellhole we went through to try and get faceplates made, and then trying to get things anodized. And Grant, of course, wanted wacky artwork on it, so that was like 4 more horrible processes. Yeah. And the whole thing was just a mess. And it seems like now, because of facilities like yours, things like Metal Photo and some of these other
Metal Photo's made getting faceplates quite a lot easier.
Yeah.
I used to do, at 3 local shops, I'd get them laser cut aluminum, take it to get anodized, and then take it to get silkscreen.
It was terrible.
And it was terrible. I had to drive all over the place. It took a long time. It was an 8-week lead time to get my panels done.
Right.
So now Metal Photo's like 3 to 4 weeks, and you get your design in, and everything's usually pretty good.
Yeah, so it's really amazing that this kind of stuff can happen. Now, where do you see? You're in the interesting position of being kind of at the driver's seat, of seeing people with modular ideas come walking in the door and saying, "Can you make these for me?" Mm-hmm. Where do you see a lot of the innovation coming from? And I ask this from a very specific standpoint. Okay. So I teach in a local art school, and a lot of art education now is involved in sort of very simple electronic design, oftentimes using an Arduino, or in some cases an ARM board, but almost always an Arduino, and some supplementary electronics and stuff like that. And I'm curious to know, do you see those people kind of moving into the design phase?
There's a lot of people using Arduino and Arduino-based things in doing Eurorack modules and designs.
Really?
Yes.
I mean,
I don't want to give you any specifics.
I did a thing, but you're saying that when we see digital stuff, we're a lot of times seeing an Arduino.
A lot of times you'll see some Arduino-based things, both our classical Arduino and now some Teensy-based stuff. Oh, yeah, which gives you a lot of power and a really easy way to use it, which is cool.
So you personally are doing designs using digital stuff.
I am. I haven't done C since high school. Mm-hmm. I write in assembly, so I'm doing it the wrong way. But if I had time to learn C, I would learn it.
I'm telling you, your hand soldering surface mount stuff. You're doing assembly code. From what I can tell right now, is you take a look at a thing and you say, what's the hardest way to do that?
But it's really
that's how you accomplish it.
Well, it's the way, though, that I guess it's the way I know, and it's the assembly thing is, okay, how do I make something that I can totally know is going to be critically timed and be as fast as possible with as cheap of parts as possible?
That's actually, that's a really interesting story, and that's kind of an interesting thing to think about, because there again, talking about designers that are maybe not super skilled either in the coding or the electronics. I mean, an Arduino system gives you the feeling like you're really working close to the metal, but actually that Arduino language,
you're pretty far away.
You're far away
from what I understand on it.
Yeah. Well, you know, having done it, just like the amount of the Arduino system does a lot to make sure you don't cock it up, right? And so every time you do an analog read, it actually it slots some time. When you do a standard analog read, it does some timer-based stuff. Conversely, when you do every time you do a digital read, it first checks to make sure that you're in the proper input or output mode, right?
Yeah.
So it does a whole bunch of
So there's a lot of extra lines of assembly code, a lot of extra clock cycles going on to make sure that
just to make sure you didn't mess up something up, right?
Yeah.
And so that's where I can see the assembly just ends up. When you're done, you know exactly what's going on.
I can count clock cycles. Like on the Geiger counter, I did this. I had a couple different routes depending on what things were happening, what the modes were, and I entered no instruction cycles so I could make sure that no matter what it was doing, it was going to be the exact same time for making each sample.
Each branch,
each sample.
Yeah.
Yep. It was all exactly the same. So that you can do that in assembly because you can count your clock cycles. It's known. You can look it up on the data sheet. Everything's very, very exact. I can't port this to any other microcontroller. I can't move my code anywhere. And if I make a tiny mistake, it's really hard to find. But yeah, it's a trade-off.
So you say you can't port it, but I mean, first of all, with these kind of microcontrollers, I mean, you probably have a couple of standards you work with, and so your stuff is reusable across.
Well, the knowledge is
right?
reusable. Yeah. Some of the stuff, I'm not a formally trained software engineer, so my code is sloppy and it's not really done in a way that you'd want to hire me to do code. I can write a simple button user interface. You can hire me for that. But as far as, I wouldn't be comfortable writing a DSP algorithm in assembly. Even if I could do it, it would not be something that anybody else could look at and would be able to make sense of.
Sure, I see.
Yeah. It's the level of being a professional software engineer versus not. I'm not.
Okay.
So.
Well, but it's interesting because I think an awful lot of people can kind of scope your background, which is you start off getting coffee at a recording studio, and that's probably pretty heartening to a lot of people who would be like, I like to experiment, I like to try things, and maybe opens the door. Now, what do you see in the future? I'm always curious when I talk to builders and kind of inventors, and I would claim you are part of the inventor class because some of your designs are just wacky.
I'll try to be inventive.
All right, we'll call it that then. Yeah. But I always like to ask, what does the future look like from your side of the goggles?
Well, it's hard to say. I can give you the answer that doesn't say anything.
No,
I think the future is going to be good for modular. People still want to get away from computers. People are trying to be more creative. You're seeing more installation artwork that involves electronics. Modular is not an extension, but a parallel to that in the art world and the music world. So I've seen people gigging with modules, with modulars, with just modulars. There's a lot of it, and it's people trying to come up with a way to be creative with technology that is new and expressive and trying to do things that haven't been done before. So I see a lot of potential for continuing on the path we're on. So, and I don't think there's going to be any new format that's going to Eclipse modular. Of course, that's the famous last words.
Right.
From analog synthesis,
all of a sudden tomorrow
all of a
it
sudden
just shows
digital.
up.
Yeah,
Right.
yeah.
Well,
Analog tape. All of a sudden you have Pro Tools.
Right.
You know,
Right.
it's. But I think we're kind of slowing on Moore's law and slowing on technological advancements regarding creativity.
Right.
Yeah.
Right. So I'm in your office, and behind you is a whole bunch of modules that you're either playing with or testing
Or
whatever.
have to fix.
In front of you is a computer system, where you probably do your designs. But
Yep.
behind you is a guitar and a guitar amp.
Yep.
Do you still play? First of all,
Do
you play music much?
Not really. I wish I did. I don't have the time.
Yeah.
Yeah. I bought an Electron analog rhythm. I was going to get back into doing beats and stuff like that. Do some live techno, and I haven't touched it in months. There's just no time,
right,
unfortunately. I get my art outlet by doing designs.
Sure.
Yeah.
Well, that makes sense, and you do a great job. Now, let me ask you something, and I'll ask you in as personal a way as I can. Let's say that you, like me, had a 15-year-old kid, and he expresses some interest in electronics, in music, in art, and all that kind of stuff, much like his dad. Where would you point him? Would you point him towards something like modulars? Would you point him towards something like circuit design? Would you point him towards get a frickin' guitar and bash on it?
There's that, and there's a lot to be said for shut up and play.
Right.
So, if they're interested in electronic design, I'd say build some kits. I get like interns and people coming to me occasionally that want to get into what we're doing.
Right.
From a design standpoint. I say, all right, that's great. You've got a good idea, but you don't know how to do it. You don't know how to start doing it. How you start is here's soldering. Here's wiring. Here's stuffing a board. These are all the things that you need to be really good at before you can design something. Design takes all the stuff that you know and makes something new out of that knowledge. So if you don't know how to do anything, or you only know how to do some things, then you're not going to be a great designer. You got to be really well versed in a variety of things.
Sure.
In my opinion.
That I can't think of a better place to end than that. That was really cool. Well, William, thank you so much for your time. I appreciate it.
Absolutely. Thanks for having me, Darwin.
All right. Have a good one.
Great.
Okay, and with that, I want to thank William for spending the time with me. If you are not familiar with WMD modules, WMD guitar pedals, or any of the work that he's done in collaboration with SSF, you need to check it out. You don't have to search far in your Google search clause to find what they're doing, and they're handled by all the major retailers. You're gonna find something you love, believe me. I want to also thank all of the listeners that contributed to my Kickstarter fund. It was that recorder that recorded this interview, as well as having served as a backup for the last several. I want to thank you all. It made it fantastic. And I want to thank all of you for listening, for sharing with your friends, and for enjoying the work that I'm enjoying so much. Thanks a lot, and we'll talk to you soon. Bye.